everybody. In this video, we're going to talk about the distributive property. Specifically, it's called the distributive property of multiplication over addition, but usually we just call it the distributive property. So when I'm teaching the distributive property to my high school and middle school students, I always do it by drawing pictures because when the students have a picture version of what it means in their head, they understand it on a much deeper level. So, what the distributive property says in algebra is that if you have something that's multiplied by a set of parentheses where you have multiple terms being added or subtracted together inside the parentheses, then you can distribute that multiplication to all of the terms inside the parentheses. And that basically means or makes it so that the parentheses aren't necessary in the notation anymore. So like 2 times 4x will give you the 8x, and 2 times 5y will give you the 10y. And the reason why this works is because if I were to draw a picture of the expression 2 times 4x plus 5y, what that would look like is I would have two groups, and in each group, I would have 4x's. So there's my 4x's in both of my two groups. And then I would have 5y's as well. And all of those are being added together. So that's a picture version of the left-hand side of the equation. If I were to draw a picture of the right-hand side of the equation, I would just have 8x's. So there's my 8x's, and then I would have 10y's. And when I draw a picture of it in this way, it's easy to see why these two expressions are equal to each other. Because in both of them, you have 8x's, but on the left-hand side, they're just split up into two equal groups. Same thing with the y's, they both have 10y's, but on the left side, they're just split up into two equal groups. And so this is the basic idea of the distributive property. And obviously, when you teach this to your students, you're not going to have x's and y's. Instead, you'll just have numbers. But it's still a really important property because it can help the students with a lot of different calculations that they will be making in elementary school. For example, if you had the multiplication problem 3 times 8, let's say that the students didn't know all of their multiplication facts yet, especially the ones that have to do with bigger numbers. Well, one way they could solve this is they could say, well, I know that 8 is 5 plus 3, and I do know my times tables for 3 and 5. So I could think about this as 3 times 5 plus 3 times 3. Because if I'm multiplying by 8, I'm essentially making 8 copies of 3. And if I don't know what 8 copies of 3 is yet, I could make 5 copies of 3 and then make 3 copies of 3. And that would end up giving me a total of 8 copies. And so by teaching the students this way of thinking, it can actually help them learn their multiplication facts better because they can decompose the multiplication facts into ones that they know. And you can also help them draw pictures of this. So for example, if you were to draw a picture of 3 times 8, you would have 3 things and then 8 copies of those 3 things. So there's 3 copies, 4 copies, 5 copies, 6 copies, 7 copies, and 8 copies. So that would be a picture of 3 times 8. And then a picture of 3 times 5 would look like 3 things that have 5 copies made of them. So there's my 5 copies of 3. And then 3 times 3 would have 3 copies of 3. And so when you look at this, you can see that 3 times 8 really is going to be equal to 3 times 5 plus 3 times 3 because it's the same number of dots regardless of how you calculate it. But for students that are just learning their multiplication facts, this might be an easier way of thinking about it. And it can also really be helpful when you're working with multi-digit multiplication because if you think about what 14 times 8 is, it means that you're making 8 copies of 14. And if you pictured this, you'd have 14 blocks. And if you make 8 copies of it, it looks like this. But it's much easier to figure out how much this is if you break it up into pieces. And you say, well, I know that 14 times 8 is going to be 10 times 8, and then added to 4 times 8. And the 10 times 8 is basically like this part of the picture, which gives you 80. And then the 4 times 8 is this part of the picture, which gives you 32. And then 14 times 8 is going to be the sum of those two things. So you would add them together and you would get 112. And so this way of thinking with the distributive property can be applicable in many different ways at the elementary level, even if you never involve any variables. And one of the ways that you can help students recognize that that the distributive property is a valid. And one of the ways that you can help your students discover the distributive property or see that this is like that they're equivalent expressions essentially, is you can develop word problems that are likely to be solved in multiple different ways. For example, if you said 6 children each have a package of candy, and each package has 2 Snickers, 5 Reese's, and 4 Kit Kats, and you ask the students to figure out how much candy do they have altogether, well, there's multiple different ways you could figure this out. You could add together all the candy, so you could do 2 plus 5 plus 4, add those all together, and then multiply that by 6. Or the other way you could also do it is you could multiply each specific candy. So you could do 6 times 2 to figure out the number of Snickers, 6 times 5 to find the number of Reese's, and 6 times 4 to find the number of Kit Kats, and then you could add them all together. And these two expressions will be equivalent to each other. And essentially, it's the distributive property applied across 3 terms because you're distributing this multiplication by 6 to all 3 of these numbers, which give you these 3 products. And if the students come up with these different methods of solving them, you can have a conversation about why all of these methods are equivalent, and then the students can kind of just choose whichever one they like the best. Um, so that's a word problem example of how you could help the students discover what the distributive property of multiplication is and how it works. So I hope this video was helpful. If you have any questions, please let me know.